Hello students, today we'll be studying 3-hinge parabolic arch. We'll just go through the question first. A 3-hinge parabolic arch hinged at the supports and at the crown has a span of 24 meter and a central rise of 4 meter. It carries a concentrated load of 50 kilonewton from the left support and a uniformly distributed load of 30 kilonewton per meter over the left half portion. It's clearly mentioned there. The loading is from the left hand support reference given. So determine the bending moment, the thrust and radial shear at a section 6 meter from the left support. That's what we are supposed to find out. Here the important point here is that we are supposed to convert this text question into a geometrical figure. So how will we drawing? So as it is given, it is a 3-hinge arch. So we'll just go through this 3-hinge arch. I have drawn it here, and which carries a uniformly distributed load of 30 kilonewton per meter from the left hand support or the left half portion, and a concentrated load of 50 kilonewton at a distance 18 meter from the left support. So here the central rise is nothing but this is given as central rise, that is 4 meters, and span is given as 24 meter. We are supposed to find out the bending moment, the radial shear and normal thrust at a distance x is equal to 6 meter. So I can write the summary, that is, it is a parabolic arch. This is important because there are different types of arches. One is a parabolic arch and second one is the circular arch. Here the bending moment, normal thrust and radial shear at 6 meter from the left hand support is to be found out. So I written these questions. So I'll just go for the solution now. In the step 1 will be finding out the reactions. In the reactions, so first draw the free body diagram, that is the vertical component at A. Since it is a hinge support, so it will have two reaction components, and horizontal component is HA. In the same way VB and HB, and the loading is given and the span is 24 meters. So as per the data, so I can write plus HA, right, and minus HB is equal to 0, that is HA is equal to HB is equal to H. Say what you can say. Then we go for summation of Fy is equal to 0. Go through the figure. So it is vertical, sum of the vertical forces. It is VA plus upwards, then 30 into 12, because half portion it is the UDL. So here it is 30 into 12 is half, then minus 50 plus VB. So that's what I have written in the equation, that is plus VA minus 30 into 12 minus 50 plus VB is equal to 0. So VA plus VB is equal to 410 kilonewton. Then I'll take moment at point A to find out VB or VA. So here we'll be finding out taking moment at point A. So I can write plus 30 into 12 into 12 by 2 plus 50 into 18 meter, since it is given as 18 meter from the left hand support. So I can write plus 18 into 2 minus VB into 24. So if I just find out, so here finding, after simplifying this, I'm getting as VB is equal to 127.5 kilonewton. In the same way we go for finding out VA as a check, or we can just subtract from VA plus VB is equal to 410. So VA also is found out. Then the step 2 will be finding out that is H, that is nothing but horizontal reaction component. So here it is, either I can take the left hand portion or I can take the right hand portion. So I taken here left hand portion. So after getting finding out moment at C, I can get HA is equal to 317.5. How it is? It is plus 282.5 going positive clockwise. So here it is positive into 12, that is 282.5 into 12 minus 30 into 12 into 12 by 2, that is it is giving anti-clockwise moment. In the same way it is minus h into this distance is nothing but central rise is 4, so I written this as 4, so it is 307.5 kilonewtons. As it is a parabolic arch, so we have an equation, that is y is equal to 4hx divided by L square into L minus x, where h is central rise, x is the given distance where the bending moment, then normal thrust and radial shear are supposed to be found out. So here the distance to be found out is nothing but 6 meters. So L is the span 24 meters. So y distance can be found out. That is, we are finding out the point here. If I just show you, so this is a point given where all these parameters like bending moment, normal thrust and radial shear are supposed to be found out. I'll say their name as D there. So we will be finding out D now. So at point D we are finding out everything. So here y is equal to 3 meters we could find out. So bending moment at a distance 6 meters from the left hand support. So here it is, we can take either the left hand portion or the right hand portion. So it is 282.5 into 6. It is bending moment, so we say it is sagging, since it is making a sagging like. So here it is sagging moment. So 282.5 into 6 minus 30 into 6 into 6 by 2 UDL minus 307.5 into the y distance, how we calculate it. So it is nothing but 232.5 kilonewtons. Then we have equation for normal thrust, where v sine theta plus h cos theta is nothing but the normal thrust equation. So we are supposed to find out at a distance 6 meters. So we are supposed to find out shear force. It is nothing but vertical forces. Vertical forces at a distance 6 meters. It is plus 282.5 minus this 30 into 6 it is. So what we can find out is this one. Then in the same way h remains same, since no other horizontal force. Then theta is, we are supposed to find out. We need to differentiate the equation y, parabolic equation, y is equal to 4hx divided by L square into L minus x. And after finding out that, we will be getting 18.435 degrees. So here we need to substitute. So we are going to get 324.1 kilonewton. In the same way, radial shear equation is there, that is v cos theta minus h sin theta. Substitute the same values what we got for v and h and theta here, and we are going to get 0 here. So hence the solution of the 3 hinge arch.